Another reaction of alkenes is called hydroboration. So these names sound strange, but there's usually a reason behind them. Hydro should make us think of hydrogen. Boration should make us think of boron. And so here we've got a hydrogen-boron bond being added across the double bond. This type of reaction is really useful as a synthesis reaction because what it appears to be, if you don't look at the mechanism, it appears to be the anti-Markovnikov addition of water to an alkene. If we were just using a hydrogen catalyst to add water to this, we would predict that the hydrogen would go to the carbon number 1 and the OH would go to carbon number 2. But when this hydrogen-boron bond adds to the double bond, boron is less electronegative than hydrogen. And so here the boron is the electrophilic part. The boron goes over here and forming a carbocation here that is more stable because this carbon has 2 carbons to help it with that burden, and this carbon does not. And so the borane, the hydrogen-boron bond adds in the opposite way that we have been looking at. And the alkylborane that is formed then is oxidized by hydrogen peroxide and a base, giving an alcohol. And so what we see as the product, we're not going to be real concerned about that mechanism or anything. But what we see is that when we add with water and acid, what we've been talking about, this is a Markovnikov product, we expect that the OH will be here on this second carbon. But when we use BH3 and peroxide and a base, we get the OH that adds to the other side. And if we want to make this alcohol as opposed to that one, this is very, very useful. So what do you need to know about this? What you need to know is that if we're using BH3, then you get the anti-Markovnikov product. We're not going to go into the mechanism or anything. I think I showed you just enough that if you're curious, you can understand why it does that. But bottom line, if there's boron involved, it's the anti-Markovnikov product. So what alcohol is obtained by applying the hydroboration-oxidation sequence to 2-methyl-2-hexene? Well, let's first draw 2-methyl-2-hexene. Hexene is 6 carbons. It's 1, 2, 3, 4, 5, 6. 2-hexene is a carbon double bond from 2 to 3, and there's a methyl group up here. It's forming an alcohol. We're getting water is being added. The overall result is anti-Markovnikov addition. So I think the best approach is to say, okay, well, what would a Markovnikov addition be? Well, the hydrogen is going to add to the carbon that has the most hydrogens. How many carbons does this carbon, how many hydrogens does carbon number 2 have? It has none. How about this guy? It's got 1. As we look at this carbon here has 1, 2 bonds, 3 bonds. The missing 4th bond is to hydrogen. It's just not pictured. So we would expect the hydrogen to go here and the OH to go to the other carbon. But because this is the hydroboration-oxidation sequence, it's going to be the opposite. So that part's the same, but the OH is going to go over here. Any questions? Learn the Markovnikov addition, and then remember boron is the opposite. We're still adding, whatever it is we're adding, didn't mean to do that. We're still adding this, but it's going in the opposite direction than we expect. Markovnikov says that the OH would go over here and the H would go here, but this one's going to be the opposite. What would the name of this guy? Oh, we haven't learned how to name alcohols, never mind.